Okay, so this is just organic chemistry nomenclature, and the purpose of this is for just exposure to all the different types of problems that you can see when you're dealing with nomenclature. I can't go over everything, all the different rules, because then the video would be too long. But I just want to give you different types of problems, so then you can go and reinforce the knowledge you already have. So for the first one, let me just show you what would be incorrect. And this is for numbering, right? So when you're looking for a carbon chain, you're looking for the longest carbon chain, so you label it 1, 2, 3, 4, 5, 6, right? But what stops you from naming it the other way? And that's actually a rule, because you can label it the other way and get a different answer, right? You can get this answer, 3-bromohexane, if you label it this way. So which one's correct? The smallest number is always the more correct answer, right? Because technically this exists, but this is the correct answer, because you want the smallest number possible. So in this case, you just label it from right to left, and then so it'd be the third substituent, so you'd have 3-bromo, and then since there's 6 carbons, it'd be hexane. So 3-bromohexane is the right answer. The next problem, notice how it's the same carbon chain, 6 carbons, so it'd be hexane. Hex is 6, and ane is just single bonds. Notice how on the third substituent there is 2 substituents. The third carbon there is 2 substituents, and then because of that, it would be 3,3-dibromo. And whenever you're naming through alphabetical order, right? So if it was bromine and fluorine, right? Or just if they were different substituents, the di part doesn't matter for the alphabetical. So just remember that di, tri, those names don't affect the whenever you have to determine between different alphabetical rules, or when you're trying to name it in alphabetical order. So moving on, we have our first ring structure. So whenever you have a ring, you have to make sure you put cyclo, right? Because if I didn't put cyclo, then how would they know it's a ring? They would just assume that it's a straight line carbon chain. So the cyclo is really important to know that it's a ring. So it'd be cyclohexane, right? Because there's 6 carbons. And then notice how I didn't actually put a number, because since there's only 2 substituents, I can actually just put trans. And trans means that they're different stereochemistry. So it means that one bromine's a dash and one bromine's a wedge. If I put cis right here, that means that both of them are dashes or both of them are wedges. And then once again, since there's 2 of them, we put dibromo. So the next one, so this one's pretty complicated, and it involves a lot of different rules that you'll have to touch up on. But I just want to show you this so you can gain exposure. So I put E right here, right? Because that's for double bonds. And so whenever you have double bonds, you'll have to follow the double bond rules. But in this case, since you have carbons on opposite sides, it would be E, right? Because if you follow the rules, this will be a higher, it'll be higher than the hydrogen here, and then this one will be higher priority than the hydrogen here. So since the higher priority substituents are on opposite sides, it'd be E. And then the other thing is that I put the double bond first, right? Instead of labeling it right to left, I labeled the carbon chain left to right. And that's because of the hierarchy in OChem. And what that is a list of different priorities that are given to different molecules, to different substituents. So for example, in this molecule, the double bond has a higher priority than triple bonds. So, and out of all the substituents, the double bond gets the priority. And because of that, that's why we label it left to right. And that's why we put 2 right here, instead of going from right to left, we label it left to right because of the double bond. So the double bond will have the smallest number. So the other thing is for the triple bond, I put 6-ine, right? Because you always count the start of the double bond or the triple bond, right? You don't say 3-ene, you say 2-ene. Over here, same thing. You put 6 instead of 7, so 6-ine. And finally, we have the bromine, which is on the 5th carbon, so it'd be 5-bromo. And then the overall carbon chain is 9 carbons, so for that, the abbreviation is non. So overall, it'd be E5-bromo non 2-ene 6-ine. So moving on to a more complicated cycloring. So for this, once again, you need to memorize the list of higher priority substituents. I'll also put that in the link, so then you can memorize the order. So in this case, alcohol is a higher priority than a double bond, and that's why we put 1 right here at the alcohol instead of the double bond. So 1 will go here, we'll have alcohol, and then you just start 2, 3, and so it'll be cyclopent, right? Cyclo because it's a ring, pent because it's 5 carbons, and then 1 would be ol, right? So because ol is the abbreviation for alcohol. And then finally 3 is the beginning of the double bond, so it'd be 3-ene. So overall it'd be cyclopent 3-ene 1-ol. Moving on to the final example. This is a case where you actually have to determine which carbon chain is better, because for the addition rule, you want the smallest number possible. And so your numbers have to add up to the smallest number. If you notice here, the numbers add up to 10. If you notice here, the numbers add up to 8. So let's go over the incorrect method. So if I label this from right to left, 1, 2, 3, 4, 5, let's label the substituents, right? So overall, since there's 5 carbons, it'll be pent-ane because it's single bond, so ane is for single. And then let's look at the 3rd carbon. On the 3rd carbon, we have a methyl and a bromine. On the 4th carbon, we have a methyl. So we'll group the bromine separately, so we'll say 3-bromo. And then for the methyls, we'll put 3,4-dimethyl, right? Because there's 2, dimethyl, and then pentane. So let's add up the numbers. 3 plus 3 plus 4 is just 10. And but if we do it this way, we actually get 8, right? So let's look at it this way. So I labeled this one from left to right, 1, 2, 3, 4, 5. So once again, we have 2 and 3, right? So we have a methyl on 2, we have a methyl on 3, and a bromine on 3. So in this case, it would be, once again, pent-ane is 5 carbons, ane is the single bond, and then 2 methyl groups, so it'd be dimethyl, so that'd be 2, 3, and then 3-bromo, right, because it's on the 3rd carbon. So it'd be 3-bromo, 2, 3, dimethyl pentane. And let's add up the numbers, so 3 plus 2 plus 3, right, so that'd be 5 plus 3 is 8. So this is a smaller number than 10, therefore this would actually be the better answer. So I hope that helped, and thanks for watching.